Today's lesson is Module 2, Lesson 11, Fraction Multiplication and the Products of Decimals. We talked about, again, the word yesterday, products, means to multiply. Product is the name of the answer when we multiply. So today we're going to look at the relationship between fractions and the products of decimals when we multiply. Okay? You already started by solving this example on the board. Okay, so what was the answer? Somebody want to share their answer? What did you get?
I got 0.877.
Okay, so your answer was 0.877. We have been talking over and over and over again about, is your answer reasonable? Look at the cartoon on the board. Think about it. $70 for lunch. Would that be reasonable to pay $70 for lunch? My daughter and I went to lunch. Her food, my food, and lunch for Mrs. Mirabella came out to less than $20. That was for 3 of us. $70 for one person for lunch isn't very reasonable. So think about what you have and does this make sense? We can prove. Today we're going to look at proving that when we're multiplying, then one of the biggest mistakes students make when multiplying decimals is putting the decimal in the wrong spot in their product. So that's what we're focusing on today. Is your decimal in your product in the right spot? 6 period, somebody's answer was 44. There's a big difference between these two answers. So let's take a time out from the actual product and take a minute to prove that the decimal is in the right place. On Monday and yesterday, we talked about using estimation. So I asked you to solve this all the way on the left of your notes. So next to where you actually solve this, I want you to write estimate. Estimating is one way you could tell if your answer is reasonable. So let's just take a look at the whole numbers that we have here. All right, so I have 34 and 12. So let's estimate 34 times 12. So if I use estimation, I see that my answer should be about 408. Are either one of these products close to 408? No. So it looks like our decimals are in the wrong spot somewhere. So we made a mistake. There's another way that we can check or prove that our decimal is or is not in the right spot. So draw a line here because that proof is over. Now let's try a second proof. Decimals. These are decimals. I wish there was something else that meant the same thing as a decimal. Another way that there's another way to write a decimal? What's another way to write a decimal? Look at all these hands. What's another way to write a decimal? A fraction. So why don't I write this multiplication equation as fractions? So I have 34. So here's my second proof that I'm going to try by using fractions. This was proof 1. This is proof 2. How do I write this as a fraction? How am I going to write that as a fraction? Well, 34 is my whole number, and that decimal is 62 hundredths. That's exactly what we worked on earlier in the week. Let's take a look at this second decimal. How can I write that decimal as a fraction? Well, 12 is my whole number. How do I write 0.8 as a fraction? That's right, 8/10. So does anybody have a question on where those fractions came from? Some good questions to ask would be, where did the 100 come from? Where did the 10 come from? Where did the 62 come from? Are there any questions? No. Do we need common denominators to multiply? No. We only need common denominators when adding and subtracting fractions. We do not need common denominators for multiplying and dividing. Excellent question, one I didn't think of. Very good. Okay, what is my rule for multiplying fractions? This was on your quiz on Friday. What do I have to do when I have mixed numbers? Before I can multiply fractions, what do I have to do? This is a little review. 4th grade, 5th grade, this is nothing new, so don't panic that this is new. We're going back. What's the rule for multiplying mixed numbers? What's the first thing we have to do? Right, we're going to change these mixed numbers into improper fractions. These are big, ugly numbers, but we can totally do this. What's 100 times 34? Right, 3,400. Plus 62 is 3,462, and our denominator stays the same. That wasn't so bad. That's a big, huge monster fraction, but that's easy. We got this. Okay, 10 times 12 is 120. Plus 8, 128 over 10. All I did was take my mixed number and make an improper fraction. Took my mixed number, made an improper fraction. Okay? Now, what is my rule to multiply fractions? What do I do first? What's my rule for multiplying fractions? I'm going to drop down and get my highlighter again. First, I have to... Alright, I'm going to multiply my numerators. Now, those are two big numbers. This is where it gets ugly. But we can do that. Go to your margin and multiply. 3,462 times 128. Go to your margin and multiply that. Do that now. 100 times 10 is 1,000. So 3,462 times 128 is 443,136. Again, a really big, ugly, improper fraction. But that's also one that we can handle. Because we're multiplying by 1,000. But dividing. So 1,000 goes into that. 443 times 136 left over. And 1,000 is still our denominator. I took this mixed number. I took this improper fraction and made it into a mixed number. So I'm almost done. I almost have my product. I'm going to take my fraction and turn it back to a decimal. So that's my product. That's my product. Is that close to either one of these answers? No. So my two different proofs show that my answers are wrong. My products are wrong. This product is way off. This product looks like the decimal was probably just in the wrong spot. I bet if they continued writing their answer, it would look like that. So it looks like the decimal was in the wrong spot.
How did you get from 443 and 136?
That's a comma. I just divided 1,000 into that number, and it went in 443 times. Just the same way dividing your numerator by your denominator. Just like how if it was 8 over 5, 5 goes into 8 once with 3 left over. That's what I did, just with a really big number.
Yeah.
Okay? Let me get that out so I don't confuse anybody. Where'd that come from? Alright, this is big and hairy, but all steps that you know how to do. And that's just, I am just showing you how to prove and check your multiplication of decimals. For your homework, you do not have to do these two steps, but it's a smart thing to do. At least do the first one, the estimating. At least do the estimating step so that you can check. And what are you going to ask yourself with every answer? Is my product? Is my product? Okay. Let's take a look at the second question that you had to do for your do now. So your answer for your do now should have been this. If that's not what you got for your answer, you need to go back and check your multiplication. We're going to talk more about the decimal points in a minute. So let's look at our second example. Xavier earns $11.50 per hour times 13.5 hours. Now, I have a question for you. When we're multiplying, do we have to line up our decimals? No. Our decimals do not have to be lined up. So what is 11.5? Well, I'm going to come to my margin and estimate first so that I have an answer in my head of a reasonable answer. So I'm going to look at 11 times 13. It's probably easier to multiply like that. 13, 130. So my answer should be about 143. That's a reasonable answer. My answer should be larger than 143 because my original numbers were smaller. Were bigger. So my product should be bigger. So what did you get when you multiplied those two numbers together? 155 and 25 hundredths. Are those in the same ballpark? Yes. If your answer was 15, that's a signal that your decimal is in the wrong spot. If your answer was 1,552, that's a signal that your decimal's in the wrong spot. So your estimating just helps you realize if your decimal is in the wrong spot because these are not close to your estimate.
How do you know to put the decimal,
How do we know where the decimal goes? It's like I teach you to ask that question, and I'm so glad that you asked that question because that's the answer on the next slide. How do we know? How do we know? First of all, so I don't confuse anybody, this was your answer. How many of you have the right numbers, but your decimal in the wrong spot? Okay, good. Honesty. I like that. And you asked the question even though your decimal, So let's look. These are the two questions that you just solved. Okay? The two products that you just found. Do we see a relationship between our factors? Remember, these are our factors. Hello.
I hit the space button on accident.
That was like magic. Okay, those are our factors, and that's your product. These are your factors, that's your product. Do you see a relationship between the number of digits after the decimal in the product and the number of digits after the factors? Well, let's look at the factors. How many digits come after the decimal? 1, 2, 3. That's for our factors. Let's look at our product. 1, 2, 3. The same thing. Let's look at the second example we did. How many digits come after the decimal in our factors? 1, 2. What about in our product? 1, 2. So what kind of a rule can we come up with? Now you're just going to multiply because it did not say to use the distributive property. Yesterday's lesson told us to use the distributive property. Today we were just finding the product. Okay?
Like only confused like about the question one was the hard one, but
Okay, that's something that we can review tomorrow during extra help. Come to extra help and we can review fractions and decimals tomorrow. So we see that the relationship is the number of digits, and you can write a sentence in the box on the bottom of your note page. The relationship is that you're not copying this because this is what we just talked about. Okay, look at the number of digits after you're writing these notes down in the big box on the bottom of your note page. The number of digits after the decimal in the factor tell us the number of digits after the decimal in the product. Okay? Sure. What we realized is the number of digits after the decimals and the factors tells us how many digits are after the decimal So the number of digits after the decimals in the factors tell us how many digits after the decimal in our product. Okay, and this is what you should be writing in the box on the bottom of your note page. When you are done copying this down, on the next page there are 4 multiplication problems for you to solve. You decide how you want to check your work. You can use the estimation, or you can use the fractions. So right now you're going to solve those 4 and you decide how you want to check to make sure that you have reasonable answers where your decimal is. So I'm going to pause the recording so you can work, and then we're going to go over it in a couple of minutes. Alright, let's go over some of these answers as soon as I find the mouse on the smartboard. There we go. Okay. So 324 and 56 hundredths times 54 and 82 hundredths. You're looking at something larger than 300 times 50. So 300 times 50, that's 150,000. So think about how big your answer has to be. 17,792.3792. There are 2 digits after the decimal here, 2 digits after the decimal here, so 4 digits after the decimal here. 1, 2, 3, 4. Let's look at the next answer. Okay, Kevin spends $11.25 on lunch every day times 35.52. A nice complete sentence with a capital and a period for your answer. $399.38. All right, Gunner, he's got gas. And he can drive 399.168 miles. And last but not least, number 4. Excuse me. The area should be 286.16 square feet. A nice complete sentence with a capital and a period so that I know that you understand what the question is asking you. Okay? Don't forget that there is extra help tomorrow where we could go over all of the lessons because your mid-module assessment is on Friday.